Welcome to the Alabama Aquarium and to our Boardwalk Talks program. My name is Mendel Graber. I am one of the educators here at the Dauphin Island Sea Lab, and this is Aravind. And this morning we are going to chat with him about his research on hypoxia, that's low oxygen events. He's a PhD student in Dr. Brian Zwankowski's lab here at the Dauphin Island Sea Lab, and he's been here for about a year, and so he is going to tell us a little bit about hypoxic events, hypoxia in general, the factors that contribute to hypoxia, those things that are going on in our local waters, a little bit about his research, and maybe some of the ways that we might mitigate our human contributions to these events. So with that, I will let you tell them a little bit about hypoxia.
Okay. Thanks, Mendel. So I'm Aravind. So I'm originally from India, southern India. So I'm doing PhD here at University of South Alabama and Dauphin Sea Island Lab. So thanks for joining me. So today I'm going to talk about something about the dead zones or hypoxia. So before getting to my talk, so I have a question. So how many of you like to eat fish here? Yeah. So we all like fish, right? So what are the basic needs of their lives? Yes, oxygen and food, like we do. So the one of the most growing problems in our coastal ocean is depleting oxygen. So I have a figure here. So in this figure, in our coastal oceans, around 400 coastal bodies so now facing oxygen depletion or dead zones.
Should I pass it?
So this number is actually growing in every decade. So we all know we live in the coastal zones. So in the global, around 40% of people lives within 100 kilometers of coastal oceans, and coastal oceans have more diverse marine ecosystem, and we all know we eat fish, and our economy also depends the fisheries. So we make billions of dollars through the coastal economy. So the health of our coastal is very important, right? So but in our coastal oceans, so oxygen levels are reducing or depleting. So I'm going to talk about how. So in our backyard, the Louisiana Texas shelf, so we all know it's the second largest dead zones in the world. So look at this figure. We have upper Mississippi. So the Mississippi River that starts from the north and all the way down to the Gulf of Mexico. So this river actually carries a lot of sediments, fresh water, and also some molecules, micromolecules that called nitrogen and phosphorus. So this nitrogen and phosphorus stimulate the growth of some microscopic plants that called phytoplankton. So if there is too much of nitrogen and phosphorus, that means too much of phytoplankton. When it dies, it's falling down the bottom. So when it decomposes by bacteria, so that used up oxygen. So this is how the oxygen is reducing. So how do we know if there is low oxygen? We cannot see from the surface of the ocean. We cannot see from the satellite images. So how do we know? So we get know by fishermen or trawlers. When they spread their net and drag their net and comes up with empty net. So then you realize you are in the dead zones. So there is no fish in the net. So basically the scientists, we have high-tech instruments. So we go to the offshore and collect water samples And when you map the oxygen levels below 2, then you get know you are in the dead zones. So why the oxygen levels below 2, which is a magic number? So assume a water tank which has lot of fish, crabs, oysters. Then you gradually reducing the oxygen. So when the oxygen levels below 2, then the fish and oysters, crabs start suffocate. So they cannot breathe. They eventually die. So like I said, so there is too much of nitrogen and phosphorus in the coastal oceans. How too much of nitrogen and phosphorus? So like I said, Mississippi River, which has lot of tributaries, watershed. So most of the watersheds are farmlands. So we are growing corns, soybeans. So there are some agricultural plants, and most of the farmlands have the major cities. So lots of wastewater from the cities. These wastewater and fertilizers we use for the plants are going to the watershed and drain off into the Mississippi River and ends up in Gulf of Mexico. So this is how more nitrogen and phosphorus in the coastal water bodies. This is actually 3 times more than when there was in 1950s. 3 times more than nitrogen and phosphorus in the coastal oceans. So how to reduce, or so we actually need to reduce the nutrients, also nitrogen and phosphorus in the watersheds. Then only we can reduce the dead zone formation, right?
So let's go back for just a second and just make sure everybody understands a couple of key concepts here, because we may have some viewers who are younger, and maybe we need to explain a couple of basic concepts. So animals in the water breathe oxygen, just like animals, our lungs take oxygen out of the air, their gills take oxygen out of the water. And so Aravind is pointing out that there is, this essential resource on our coastlines, that our estuaries, our bays, grass beds, marshes, oyster reefs, they provide a lot of diversity of habitat for a lot of our fisheries species, those that we harvest from the ocean. So a lot of marine resources are coastal, meaning they are near the shoreline rather than out in the open ocean. This also happens to be where a lot of this runoff from rivers enters the ocean. And so, you have this meeting of the excess nutrients, maybe excess. So, in a what we might refer to as a natural state, or kind of a pre-industrialized agricultural state, before we're adding so much nutrient to the land, which then gets picked up by rivers and carried by streams and rivers down to the ocean. We would still be having, going back because I made a long sentence there, but before this industrialized system, there would still be sediment and nutrients flowing to the oceans from the land. However, we humans, through largely our agricultural processes that we're referencing here, are adding an awful lot of nutrients. So let's also talk a little bit about our capabilities and limitations for measuring these things. So you mentioned that this is 3 times what has been added to, I guess you mean like through the Mississippi River system to the Gulf of Mexico since the 1950s. We're at that level right now. And he also mentioned that you use kind of like the seafood industry as kind of like a harbinger of this effect, where if you think about, he mentioned you can't see this with satellites. Okay, so we have satellite systems that can tell us sea surface temperature So there's certain things that we can measure or like extrapolate from what we're measuring or detect using satellites. But if you think about how vast the ocean is and how we might sample some of these other factors, not just at the surface, but through the water depth, we have a lot of sensors. There are a lot of sensors out there, and there are people who go out and take measurements, but these are just pinpoints in the ocean. So these are pinpoints of data. So we're working, we have to use the data capabilities that we have, which have advanced remarkably, like in the age of computing. So think about how much more ability we have to measure, to store data, to process data in the computer age than we did, 50 years ago. So our capabilities have just really advanced, but still, this is a big area, and there's still a lot that we don't know. So then he's kind of, at the point in this discussion where we talk about, well, briefly, and explain some of the finer points of how this creates hypoxia. So the nitrogen and phosphorus, two nutrients, and why do we call these chemicals nutrients? Why do we characterize them as nutrients? What do nutrients do? They nourish something. So in this case, he mentioned the phytoplankton, the algae. So they photosynthesize, they're plant-like, and as we put these nutrients, these fertilizers on our crops to stimulate plant growth, they will also stimulate the growth of the phytoplankton, the algae. And so if you think about this a little bit, you might think to yourself, well, algae produces oxygen through photosynthesis, like plants produce oxygen through photosynthesis. So how does this result in a low oxygen situation?
So this is, so we all know, so when you mix up the water and oil, so oil lies in the top and water should be in the bottom, right? So we can see the separation between oil and water. Similarly, so this is actually due to the density difference between oil and water. So similarly, the fresh water has very light and low density, and salt water has high density. So this separation, so this also causes a separation between surface and bottom waters. So we know the oxygen, water absorbs oxygen from the atmosphere, but this oxygen cannot penetrate into the bottom water because the density difference that surface water always lies at the bottom and salt water in the and salt water in the bottom. So this separation prevents the penetration of surface gas into the bottom water. So when all the materials died and is sinking into the bottom, then decompose and consume more oxygen. So they used up only available oxygen in the bottom. So there is so we know that the light also has some limitation. So the plants grow only in surface layers where you get more light. So in the bottom you would have light and no plants growth, and there is no much oxygen. So due to this separation, so the surface oxygen cannot penetrate to the deeper, and when all decompose, the bottom oxygen that used up. This is how, especially in bottom waters, we see dead zones or hypoxia.
So the decomposition of this dead algae, and often you'll have what we refer to as a bloom, which is, they don't have a flower, but it's just when you have a lot of algae growth, the phytoplankton growth, and then they'll hit some other limiting factor to their survival, their growth, their thriving, and then you may have like a big die-off, and then the bacteria, start to consume this dead algae material, and bacteria use oxygen. as part of their metabolic process. And then you've got this, you can have this stratification between the surface waters and the bottom waters related to density. And so most of the oxygen, as he pointed out, is going into the water at where the light zone is. That's where you've got the photosynthesis, where these algae, the phytoplankton, they're living, they're producing oxygen, and also where the oxygen from the atmosphere diffuses into the water. So sometimes you end up with a very strong stratification. So this is where, you know, we're introducing more complexity to this concept. So there are a lot of factors at play that will determine, like, the size, the extent,
especially we see in the summer season, so where the wind speed is very low. So what happens when high wind speed, that can mix up the surface and bottom water. So that means that helps to penetrate the surface to bottom. So but during the summer season, we don't have much wind for this mixing. So then, especially in the summer season, we see more dead zones because of more stratification in summer season.
Yeah. So the dead zone, you know, that's kind of like the catchphrase that we use for it. In the Gulf of Mexico, is becoming more persistent. People, you know, more people know about it, and so, you know, this is something that people have as sort of a familiar frame of reference. But we have, as Aravind passed the map around, like this increasing incidence of dead zones in our coastal oceans. And we do occasionally have hypoxic events in Mobile Bay. And so I don't know if you have looked at any of the jubilees in your work. You did mention an event over in Bon Secours Bay recently.
Yeah, I think few years ago, the shrimps and crabs, they died due to the low oxygen and piles between the surface and pushed into the shores. So we can see many dead crabs and shrimps in the shore.
This is Bon Secours Bay right here. It's a little embayment within Mobile Bay.
So you were talking about the Mississippi River and how nitrogen phosphorus levels are 3 times higher than they were in the 1950s. Is there a similar trend with the Alabama rivers that feed into Mobile Bay?
Yeah, we sometimes we also see the low oxygen events in Alabama, especially in the mouth, even Dauphin Island Station, Bon Secours, and some other stations. Yeah, so we expect if more nutrients it just brings through the rivers, then we expect dead zones even in Mobile Bay.
So do you want to tell us a little bit about what you've been working on for the last year?
So I'm kind of focusing how the natural process also cause dead zones. So we were talking about how human activities that cause dead zones in the coastal oceans. But it's not only the human activities, but also some natural events that also cause the hypoxic or dead zones. Similarly, stratification is one of the physical processes, and other processes when wind blows in certain direction, so that can push the surface water and the bottom water comes into the top. So like I said, so nutrients or nitrogen phosphorus that stimulate the growth of phytoplankton. When they die, they decompose, right? So then if when they decompose, this nitrogen and phosphorus back into their original form. So that means bottom water also has high nutrients. So when wind pushes the surface water and bottom water comes into the top, this bottom water has also high nutrients or high nitrogen and phosphorus. This can also create the same processes again stimulate the growth of plants, phytoplankton. Even they can cause formation of toxic algal blooms that can kill millions of fish within a day. So this is one process, natural process. Another process is Mendel also mentioned the warming temperature. So we know we make soda with cold water carbonation, right? When that means cold water, we mix up cold water with carbon dioxide under certain pressure. So that means cold water can hold more gases. So vice versa, warm water cannot hold more gases. So recently the trend shows in our coastal oceans the temperature of our coastal waters is rising. So that means very few oxygen is diffusing into the water. So
If you remember, like back to your basic chemistry, maybe high school chemistry, if you think about like when molecules are warmed, they become more energetic and expand. And so when water is warmed and the molecules are expanding, they don't hold that dissolved oxygen as well. So I always like to make sure there's no confusion that the water molecule H2O, this is not the oxygen of the water molecule is not the oxygen we're talking about that gets dissolved into water. So there's O2 gas, which is what we breathe, what's in the atmosphere, and that, gets dissolved in among the water molecules. But when those water molecules are warmed and they expand, they don't hold that dissolved oxygen as well. It comes out more easily and it doesn't diffuse into water as easily. So this is another factor that kind of complicates an understanding of this process. So this warming, the warming of our coastal oceans contributes to this as well.
Another question. So you were talking about surface winds blowing water and then bringing more nutrients to the surface. Does that only happen when wind is blowing a certain direction? Like,
Yes.
Have to be, you said
yeah, so when wind blows in certain direction,
yeah.
so then only, especially in northern hemisphere,
Yeah.
wind has a tendency to turn right when they blows. So if it blows this way, then it turns right and push the surface water to the offshore. Then more bottom water comes into the onshore.
Yeah.
So a lot of people are interested in the phenomenon of the Jubilee in Mobile Bay. So let's talk about the Jubilee a little bit. So the Jubilee happens in Mobile Bay, like in the northeast part of Mobile Bay. And it has been known to happen here, it's been documented here since the 1850s. So this is kind of on a near annual basis. So this is kind of one of these, kind of a case study of this pre-industrialized hypoxic event. And it's one of the only places in the world where this has been known to happen in that way, like at a near annual frequency and before before industrialized agriculture. So it's kind of an interesting case study to examine the jubilees of Mobile Bay and consider some of these natural, the natural factors and then the ones that we are kind of strongly affecting, that humans are kind of strongly affecting.
Yeah, I assume this can also due to the high nutrients load through the rivers, and also like I said, some wind direction in Mobile Bay can also cause these high nutrients or high nutrients bottom water that that brings into the surface and happen and the same process decompose dead material is decomposed by bacteria and consume more oxygen. So these are the
Well, another factor is that the shape of the coastline.
yeah.
Mobile Bay and where that happens. At the northeastern part of Mobile Bay. So we've been talking about a lot of the different factors that contribute to these hypoxic events. And to add to that list is the shape of the coastline, not just at the surface, but also like the subsurface shape of it as well. And so then you've got, as he pointed out, the winds are one of the major contributing factors to this. And so when these sort of specific set of conditions occur, that's when we see these hypoxic events.
So what is, okay, I'm from Wisconsin. Thank you. What is a jubilee? Thank you.
Because that sounds like something good.
Exactly. It's this exciting knee deep water and scuba food, which are animals that are fleeing from a wall of low oxygen water. So I think that we are kind of maybe more familiar with kind of the concept of an air mass. If you think about your local weather station, your local meteorologist, they'll talk about like a cold, you can even feel them, like a cold front, but so there are air masses where the air will, you'll have an air mass with different conditions than they can all diffuse together, but then you have these areas, right, where they might be colder, they might be more moist. So the same is true in water. So you can have like water masses. Yes, they can mix, they can like diffuse together, but then you can have areas where the water has less oxygen in it. You can have areas where the water is more strongly stratified, where you have like a freshwater layer on the surface and saltier water at the bottom, or it can be well mixed where it's more homogeneous. So there are a lot of times, as he was saying, at the bottom you've got things like crabs and shrimp and flounders, and they're fleeing from that, trying to get to oxygen. Well, it's often like herding them up onto the shore. So that is a jubilee. People would get excited. They go out with their buckets and collect all this seafood, and they were jubilant about it.
Big party.
Yeah.
A couple of questions about the jubilee. Is it okay if I ask about jubilees?
Yep.
So when these jubilees happen, let me organize my questions in my head. So that has to do with depth, right? The amount of wind, right?
Yeah.
And then like temperature. So my question is, at the side of the bay where that's happening, like how deep is it, and like how does that water stratification kind of like between the low oxygen bottom water and the like surface? So what's the depth like where that's happening? And then you said in the summer we don't get a lot of wind. So is it wind, like kind of anomalies in the summer that are causing this? And then also, have we seen an increase in these phenomena? Since 1850?
I assume this might be due to the changing the wind direction.
Okay.
So we usually have certain direction of winds, but when it's changed, that can, so like I said, push the water or draws the water in the surface.
Okay. So it's changing wind direction
Yes.
in the summer that cause this. So like a Mary Poppins, when the wind changes,
Yeah.
it happens. And then, have these events been kind of increasing since like our kind of increasing nutrient loading?
Yeah, this is like Mendel said, maybe it depends the continent shelf or that particular area. So how this oxygen or how long these events occur. Sometimes these events occur just 2-3 days, then remix again more oxygen. But sometimes these events persist longer than even 5 or 6 days. Then they don't have oxygen in long days, then they eventually die. So it's dependent upon the duration of these events occur.
And let me also say, we've been talking about some of the complexities to studying and understanding, these issues. And also, let me just say that you can study this from different, like a different perspective or with different objectives too. So, like, Aravind is a physical oceanographer,
Yes.
right? So, he's looking at some of the physical contributions of this event, but, to add other ways of looking at this into that. So he's mentioning that you might have like a big die-off, but you might also have that just lasts for, a few hours a day. But then you might also have a more persistent event where the animals are not necessarily done dramatic and obvious, but they may be experiencing what we might call like sublethal effects, where they're in a low oxygen environment and it adds stress. And so they might succumb to that or something else when you have these compounding stresses. Maybe it affects their reproduction. So you've got these other ways of looking at these hypoxic events. So, yeah.
Sorry, I have another. I
Yeah.
have another question. It's kind of a little different topic. So you're talking about like these physical factors, right?
Mhm.
And you said that we can't see them from satellite imaging, which would be really nice. You just take a picture and then know what's going on. So how do you measure this, either in the bay or offshore? How do you get this information to know about the wind or the oxygen? Yeah.
Yeah, I mean, we cannot observe the condition of oxygen. We cannot measure from the satellite images in bottom water, but we can know the winds, what direction it goes. So, is this cause the surface upwelling, or that draws the bottom water to the surface? We know all these things. So, so we know these steps, and maybe the precipitation. So high precipitation can cause high discharge. So the discharge also bring lot of nutrients. So we know all this stuff. Then we can think about these reasons may cause low oxygen events. Then at in these periods we go to the water and measure the oxygen. So then
Predict from
yes.
physical, like other things that
We can predict to some physical process like wind, precipitation. So we expect this process can lead high nutrients load or the draws subsurface water to the surface. So then we go to the water and measure the oxygen.
So the purpose of the prediction would be to like constrain where you're looking for this event. So you might have different reasons for predicting, for making a prediction, but in this case you're talking about like identifying a place where you might go and look based on conditions that you would predict might cause a hypoxic event there. So you're looking at like natural causes or contributing factors to hypoxic events, and
Especially
Can I ask a two-part question?
Yeah.
The first part is, what specifically is your research question? What are you trying to answer? And secondly, how are you going to validate the answer to that?
so I'm focusing. So we know with this area, that zones in this area is well documented. So what about the eastern sides of Mississippi River? In this region, in some observations, we found low oxygen events. So how low oxygen events, particularly in this region? This is my research question. So how?
What's your research hypothesis? Talk to me like you're talking to somebody on your committee.
That's how to make grad students sweat.
I've done this before.
So I am actually trying to figure out how the oxygen events, in particular in this region. So what are the physical drivers like wind or river discharge or stratification? So what predominantly drive these low oxygen events?
You've given me a very qualified research book. Specifically, if you were to say, my null hypothesis is, what would you say? Or tell me, just give me your alternative hypothesis.
So especially,
What are you
yeah,
trying to answer?
especially through the observational modeling efforts, so we can predict these low oxygen events.
So you want to predict.
Yeah, using some
So are you
models.
gonna come up with a new model then?
Yeah, not new models. So using some existing model, so we can give some forcing and we can predict these events through those models
Okay, so how are you going to validate this?
through observations. Because we actually through these models we actually calculate the historical oxygen levels. Then we have the observations, right? Then we compare both. Then what difference these observations and model results? If it's matching, then we can say the model is good for predicting the future.
So what kind of input goes into the model? Wind,
Yeah, there are a lot of we put atmospheric, solar radiation, wind, and
solar radiation, wind.
yeah, and humidity and all other atmospheric things, all atmospheric parameters and water temperature, salinity, currents. So even currents or water currents that can bring logs in events to one position to another position. So we give all these inputs in the model, then we predict historical how oxygen levels changing or varying in last 40 or 30 years. So then we have some observations results, then we compare and we match how these observations and these model results is how much bias, how much error in this model. So
what is, I mean, you sound like you're talking about other people's research. What is your contribution to this whole thing?
yeah, I'm actually looking multiple stresses, these stresses, how this contributes in this particular area, because the study in Alabama shelf is not yet done. So
It's what?
It's specific.
study in Alabama shelf. So the hypoxic or low oxygen studies in Alabama shelf is didn't pay much we didn't have much attention or nobody has done before.
Okay,
So-
you're just specifically.
Specifically,
sticking to
yeah,
Alabama.
Alabama shelf, yes.
The Alabama.
So what are the major challenges facing you? In
Yeah.
completing your research, that is.
One thing is we need observation results. So we need to go offshores and especially that also need money. We want to go to the offshore and collect the samples and process it, and comparing the model, and we need to tune the model. So we need to get the accurate results, right? So we don't know this model performs well or not. So we need to tune the model. So there are we need to consider many parameters to tune this model. So these are the challenges. Yeah.
I have a question that's probably a little simpler. He actually, the questions he asked helped clarify some things for me. But one thing that you, going back to the Jubilees, are we seeing that happen more frequently now? And perhaps this was answered and I missed it, than what we've seen in the past? Because from what you're saying, the Jubilees are actually being caused by the lack of oxygen. So are we seeing more Jubilees? Are we seeing this phenomena of
Yeah,
the seafood coming ashore more frequent now?
Yeah, this is so. Like I said, so I'm using the models to predict the low oxygen events, right? So first we actually predict the historical historical low oxygen events, and when then we compare with the observations. So once these match up, then we can predict the future. Then we get to know how frequent these events can happen in future.
But are
And-
we seeing it happen more frequently now? Because he said that it's been something that we have observed
Yeah,
since
that's-
1950, is that correct?
It's been done.
Are we seeing it happen more frequently now?
Yeah, especially I specify in Louisiana, Texas shelf. Yeah, so because Mississippi River is fourth largest river in the world, so it can bring tons of nitrogen phosphorus, right? So that means tons of nutrients into the Gulf of Mexico.
Right.
But
So to clarify, he's talking about like a measurement of nutrients.
Right.
So 3 times this is what was measured.
Right.
I don't know like the period of measurement. I don't know. I'm just repeating, what he said about the measurement of nitrogen and phosphorus specifically, moving through the Mississippi River and being deposited in the Gulf of Mexico, if we get really specific. So to give you a little bit more information about Jubilees. Jubilees, that's not like a generalized term for hypoxic events. That is an event that happens in Mobile Bay.
Right, no, I understood that.
Okay.
I was just wondering if we're seeing an
But
increase in
but we don't necessarily have that measurement. So to give you a little bit more information about Jubilees. Jubilees are, they happen like over the course of a few hours, or maybe not even that long. So now I'm not saying that it's all set up in that period of time. I'm saying like that's what the people would observe, the people who live on the shore. So it's a cultural phenomenon where if you live on the northeastern shore of Mobile Bay, you might see a jubilee. They also tend to happen in the middle of the night or like the wee hours of the morning. And so you will have people with phones, will start ringing. People will go out to the shore with their buckets ready to scoop up seafood. It's over, just to kind of give you a picture of this. It's over before, if you called your friend in Mobile and said, get up and get over here, it's likely to be over by the time somebody gets over there. So yes, these are distinct events, but they're not it's not like they've necessarily been recorded with a lot of accuracy. It's not like the records of this can be accessed since like 1850. So we know that they happened, and it's a regular event, but it's not like there's necessarily like a record that he could access that says, okay, there was a jubilee on this date. It lasted, so that record is not necessarily there.
And they're not predictable.
It's more, there is a record, but it's more anecdotal.
You know, it sounds
Yeah.
like
That
this
was-
research is gonna help try and predict.
Yeah.
Yeah.
I understood the prediction part and what
That
you're
would be
trying
very
to
cool.
achieve. That I understood. I was just wondering if this is one of the things that we're seeing happening, with climate change. We're seeing the jubilees happen more frequently, or
Well, one of
that
the
is an indicator.
right. So one of the things we know is that this is happening in a lot. So again, Mobile Bay is a kind of an interesting case study because we know of this regular event for a long period of history, but it was one of the only one of only a couple of places in the world, to kind of give you an order of magnitude for context, where this has been documented like that. And so we do know that these hypoxic events are happening in a lot more places. They're happening more frequently, and they are more persistent.
That
But-
answers
Now.
that
But
question.
you don't know whether it's due to, climate change or increased nutrients being washed off from.
Well, you can't necessarily assign it to one or the other. I mean, you could kind of refine that question and say maybe one or the other is a bigger contributing factor, but they both, are like a part of the system that contributes to these.
But we do know that they're increasing, so we do know that oxygen levels are being impacted by probably more than 2 or 3 things. But
Right, yeah.
that it is happening, and it's happening more frequently, which is really the basis of my point.
Like worldwide,
We're
yes.
seeing it more frequently, Thus, we know that this is becoming a bigger concern.
Yes.
And we're all doomed.
In,
Researchers who are looking at like a specific area, like Mobile Bay. So he is working to refine our understanding of this. So
Specifically to Alabama, which is wonderful.
yeah. Growing, the dead zones are growing number in coastal oceans. So Louisiana Texas shelf is well documented, and Alabama shelf is not well documented.
So that's why
So
you're focused,
yeah,
because it's not well done.
so like he said, so climate is changing. So how often these events can occur in under this changing climate?
Can we look forward just a little bit? I mean, concerning you personally, are you going to remain here in Alabama when you graduate, or are you going to go someplace else? How do you translate what you're working on now to what you're going to be doing in the future?
I haven't think about that.
It's not that far ahead.
You're from southern India, do you see that, I mean, are you close enough to the coast, do you see that transferring to work over there in some fashion?
Say it again.
do you see that translating to your home in southern India? Were you coastal there?
No,
No?
no.
It's unique to this area.
I mean, hypoxic events aren't. They're becoming worldwide. But you said that you master's work, right? So like current, ocean currents? Is that what you, what did
Yeah.
you work on for your master's?
Heat content.
Heat?
Heat, yeah.
So, you know, this work helps kind of like, if you think about the resolution of, you know, if you're focusing on an issue or an area, you know, and maybe you've got sort of a big picture issue, big picture resolution of an issue, you know, then the more we learn, the more we can kind of fine tune that understanding. So you're kind of working with computer models?
Yeah, I'm going to use a hydrographic model. Yeah.
And then also maybe do you use like the satellite data that's available, or these models use the satellite data that's available?
Mostly I will be using the observations. So we go collecting the water samples and other data sets, river discharge. So these data sets, then we use all these together and put into the model. Then we predict how often. So we don't know about historically where the locked in events in this area. So we want to first predict what was the case in historically in the Alabama shelf. So yeah, we found some hypoxia events recently. So we want to know this was already there or it's just a recent climate change or change or that caused these events. Like, yeah.
So, for example, if you were sort of like putting information, like parameters into a model, just say, for example, if wind conditions are this, speed, direction, if water temperature is this, if rainfall is this, if you set these different parameters and say, I'm just throwing this out there as a question, but it's kind of an involved question. So if these conditions are met, and you kind of like lay out the conditions or a range of conditions, we predict that there will be a hypoxic event. And then if you lay out those conditions, feed them into the model makes a prediction, and then you go out and you check. You like go out, okay, is there a hypoxic event? The model predicted there would be a hypoxic event using our parameters. Did a hypoxic event occur? So you go out and check, and then if it didn't, then you would use that information to kind of refine the model.
Yes.
Okay. Or refine your parameters that you
How many
input.
hypoxia events do you need to detect in order to validate your research? I mean, you can't just do one.
Yeah, I mean we have some hypoxic events, so under various reasons.
Also, you look at historical data.
Yeah, I want to.
Validated
Yeah, I
data.
want to check the historical data sets. So when we have the model results,
But that has become a bit of a problem because this area hasn't had that much research has been done.
yeah,
So what historic information is there if there hasn't been a lot of research done here at the Alabama shelf?
Oh, but you're saying that you've collected a lot of information in terms of all the parameters that go into the model, and you know when hypoxia events have occurred. So you
Right,
can
in the
then
past.
feed that into it, and then look at
Historic
the
from
past.
other areas, gotcha.
So you're like piecing together data sets.
I missed it.
So like a data set of known hypoxic events and then the, meteorological, hydrological data set, if there was one that kind of existed that you can like,
That's really cool,
cross-reference.
though, that you have
right? Am I?
that. So
Understanding
you're
what you said?
Applying what we learned from other areas to the Alabama shelf.
so yeah, suppose we have an hypoxic event in 2019. So we can using the model, we can predict the oxygen levels in 2019 and match up with the observations. So whether these models predicting the hypoxia events, then we can predict the historically how often this hypoxia were occurred in even 90s, 70s, 80s, 90s, whatever. Yeah.
And what would be the motivation for doing this? Like, why do we want to predict hypoxic events?
To get a doctorate.
Yeah, it's important to mitigate these events and sustainable solutions, right?
So if
yeah.
you predict, it maybe creates a sense of urgency in dealing with this issue. So if you create a model that says, if we continue doing this, we're going to see this impact, then
So,
maybe you can create a sense of urgency and help people understand that we have to mitigate this.
Yes.
That we are strongly motivated to mitigate this. We like seafood. This is an important food resource. It's an important economic engine. So if we don't do something to control the runoff, the nutrient runoff, then this is what's going to happen. This is what we predict will happen. Yeah.
So someone had asked you how your research in this area might serve you later, right? So with these models, you can often apply them to other areas, right? And just modeling in general is a good skill. So you can take the skills you're learning and apply these to other areas of the globe, right?
Yeah.
Okay. Yeah.
So we can leave this here, this product, this will be, like a product of his PhD research here, and it, can be used here in Alabama. But then the skills that he gains from going through this, and this can also be, not just that, but maybe some of the inputs for the model. Of course, it's so. The factors are so complex, and it's so kind of like specific to particular areas, but still you can kind of like translate that in certain ways, kind of, using.
Yeah.
It's,
Yeah, we can say this particular reason that cause oxygen. So if you reduce or if you try to control this, then we can mitigate this event, or we can control these events. Yeah.
You might end up with certain kind of, and the more this is done, the more scientists might be able to identify patterns. So say for example, you've got a certain amount of discharge out of the Mobile Bay watershed. So what you see in green here is the Mobile Bay watershed. All of that land flows into Mobile Bay, and we have a lot of data about the water flow, the water volume that's flowing into Mobile Bay. And so say you can measure water volume You can measure the volume of Mobile Bay. You can measure the nutrient inflow. And say you can detect some patterns that would be, some sort of threshold of nutrient inflow to water volume that would be kind of like a red flag. Maybe?
Yeah.
Sort of like translating this to other areas. So would you offer something as kind of like the big picture message of either hypoxic events or what you're doing in this area?
Yeah, I'm trying to figure out how these physical stress that cause low oxygen events. So suppose even we know that in our region also hurricane prone region. So every spring or late fall we have more hurricanes. So how these hurricanes might influence two types. It can actually enhance the precipitation, and so the more river discharge through the rivers, and also this can resuspend the materials in the bottom. So again, more oxygen is needed to decompose all of this. So
So you're throwing another compounding factor in there with hurricanes.
Yes.
So you get a lot of rainfall from hurricanes, so that might flush a lot of nutrients through the watershed into Mobile Bay, and you also get this stirring where you're resuspending bottom nutrients back into the water column. Adding some more complexity there.
Yes.
Did you have a question?
Yeah.
So, thank you very much.
It's my pleasure.
And thanks for joining us.
May I offer